Today about polynomials, section 6.1. Okay, we're going to talk about polynomials. This is almost straight out of the Algebra 1 textbook. So hopefully you can recall some of this, at least even a little bit of it. Some of the terms may be from Algebra 1. But polynomials, section 6.1. First off, we're going to talk about what is a monomial. Alright, monomial. These words come from the Latin words. Monomial comes from the Latin word meaning one term. Mono meaning one, nomial meaning term. One term. So a monomial is a number or a product of numbers and variables with whole number exponents, or a polynomial with one term. Okay, a monomial, one term. A polynomial, which is what we're really talking about here, this whole chapter, is a polynomial is a monomial or a sum or difference of monomials. Essentially, polynomial means many terms. So poly meaning many, nomial meaning terms. Polynomial is many terms. Degree of a monomial. We're going to talk about degrees of monomials and polynomials. But degree of a monomial is the sum of the exponents of the variables in a monomial. So again, one term. Oops. So if I look over there, it's kind of tough to tell. I know for some reason there's boxes around it. But 4x squared, y to the fifth, z to the third. They take the exponents, they add them. So 2, 5, and 3. 2 plus 5 plus 3 is 10. Okay. So that was our degree. Degree of a polynomial. Now, here's what we're going to talk about a lot of today, really, is degrees of polynomials. The degree of the term of the polynomial with the greatest degree. We're looking with the greatest degree. So if you look at all the polynomials there, the degree there would be the one of the largest. That would be a degree of 6. So we're going to look at polynomials with the greatest degrees today. Alright, again, today is all about classifying the terms, really. Lots of classifications. Next part of vocabulary here. Again, a lot of vocabulary here. Leading coefficient is the first one. Now, you should already know what coefficient means. Can anybody tell me what coefficient means? What's a coefficient? It's a number in front of the variable, right? So if I look here, I have a coefficient there, I have a coefficient there, and a constant, which is always a coefficient. Okay? The coefficient of the first term of a polynomial in standard form. So the leading coefficient is the first coefficient. So if you look there, it's kind of underlined already. But the leading coefficient there would be 3. Okay, so it's the coefficient of the first term. A binomial. Now a binomial is a polynomial with 2 terms. Why is it 2? Because bi means 2. And when you think of that, most people think of a bicycle. 2 wheels. 2 wheels, bicycle, binomial, 2 terms. A trinomial is a polynomial with 3 terms. And again, we think of that, we think of tri, meaning 3. And we think of a tricycle, 3 wheels. Okay, and again, both of those are kind of root words or prefixes you'd probably see in English. So you guys heard of, bi and tri in English terms, prefixes, mono. Again, it all comes from those same root words meaning 1, 2, and 3. So having those root words understands that. And then a polynomial function is a function whose rule is a polynomial, essentially just something that passes over. Alright? This table is going to be very helpful for you. You'll want to use this table probably today on your assignment even. But we're going to talk about degrees. Now, the first 3, or these 3 essentially, should be reviewed for you. But degree is what goes on with the exponent. So degree of 0 is a constant because all you have is a constant. That's like saying x to the 0 power. Anything with the 0 power is always 1, so I don't need to write it there. So 6x to the 0 is just 6. It's constant. A linear, again, there's that invisible 1 exponent, so x to the first plus 3. It's a linear. A quadratic, meaning I have a 2 as my exponent. And then a cubic. Now, why should I say those 3 should be reviewed? Because we did those when we did parent functions. Remember, we get a line graph when we get x. You get a quadratic graph when you get x squared. And you get the wave of a cubic graph we need to get third. We did those already with parent functions. So those three should be reviewed. It's the same type of work there. Okay, I still understand what those graphs would make. And then the two new ones today would be a quartic and a quintic. Now, quartic makes sense because there are 4 quarts in a gallon or 4 quarters in a dollar. That makes sense. It's the quintic that most people struggle with. Again, first period laughed at me, but how I always remember it is a quintic. You think about like a quince, it's like for a little girl it turns like 15. Quince, so it's like 5 multiples of 5. Quintic, 5. Kind of falls into place. I don't know. Makes sense to me. Somebody's like, well, 15 is, what's 15 in Spanish terms? Anybody? Spanish? Anybody speak Spanish here? Nobody's taking Spanish?
I'm in Spanish.
You're in Spanish? You don't know how to count Spanish? Yes. Yes. Uno, dos, tres?
Yeah, that's about it.
What's up, sir?
Isn't it quince?
Is it quince? Oh, that's what it is. Quince, there you go. So quince, which is very close to quintic, I guess. Did you take Spanish or do you just know that?
A while ago.
A while ago. See, yeah, he recalls. Good work. That's cool. But again, so those are the degrees. And then off over here, we have the terms. And again, these are not paired up for any reasons, but monomial means 1 term, binomial 2 terms, a trinomial is 3 terms, and then anything more than 3, you state the polynomial of however many terms there is. So if it's 4, you say polynomial of 4 terms. If there was 7 terms, you would say polynomial of 7 terms. The first 3 are the only 3 that have special names: monomial, binomial, and trinomial. Everything after that is just a polynomial of however many terms. And here's another table, very similar. We're going to talk about writing stuff in standard form today. Standard form means the polynomial goes from the largest degree on down. So if you notice, look at my exponents, I go 5, 4, 2, 1, 0. So standard form is the highest exponents on down. From here on out, anytime we do something like this, I always want you to write in standard form, so the largest on down. And we'll deal with polynomials a lot from here on out. And then we did talk about earlier, but 6 is the leading coefficient. The leading coefficient is the number that is in front of, so the first degree, so 6. All right, so let's look at an actual problem here. Number 1, I have negative 7x plus 5x to the 4th. First thing I always want to do is put it into standard form. So how would that look in standard form? What do you say, Sean? Nice job. That is standard form. 5x to the 4th minus 7x. Again, highest exponent on down. You go from highest to smallest exponents. From here, I need to find the degree. So I want to classify it. So degree is the highest exponent. What's the degree here, Jack? That is, what's the highest exponent? 4? So the name of degree. Now, what is the name for degree of 4? If you look back at your table, that might help. But the name for degree 4 is, anybody? Quartic. Nice job. That is a quartic.
What is that? The nod?
Name of degree.
Okay.
I just kind of abbreviated. Number of terms. How many terms are here in this polynomial? How many terms are there, Bailey? How many different terms are there? 2. So if there are 2 terms, we call that a, anybody? Binomial. So that would be how we would classify it. That is a quartic binomial, right there. And that's classifying it. So 4, the degree is 4, 2 terms, quartic binomial. Number 2, same idea. I want to first simplify and write it in standard form. Hopefully some of you got number 2. How would that be in standard form? What would that look like in standard form? Andy, what do you say?
3x plus x squared
Okay.
minus 2x.
Nice job. Make sure you combine like terms there. Now I'm looking for my degree. What is the degree for this one, Frank? Ethan? What's the degree? Oh. 3. The degree is 3. So the name for degree of 3 is a... Anybody?
Triactic.
Cubic. Cubic. Name for degree 3 is a cubic. How many terms are there here, Sage? How many different terms are there? 3. Which means it is then a trinomial. So that is a cubic trinomial. What about number 3? How could you write number 3 in standard form? What do you say for standard form, Reagan?
5x to the third plus x to the third minus 4x.
Nice. So degree? What is my degree here, Bailey?
3.
What's the name for degree 3, Bailey? How many terms are there, Jack?
3.
And 3 is a, how many terms? That's called a what? So that would be, again, a cubic trinomial. Nice job. Don't change it. All right. Yes, sir.
Alright, no, never mind.
Okay. You good, Sage? All right, take a couple seconds to try these 3 on your own. All right, number 4. Standard form for number 4. What do you get, Shane?
2x plus 5.
Ooh, close.
Negative 2x.
Negative 2x plus 5. Thank you, sir. So degree. What is my degree there then, John? That is degree of 1. Make sure you recognize that. A lot of students mess up on this one. They think 0, but it's actually 1. There's the invisible 1 exponent. So I have a degree of 1. The name for degree 1 is what, John?
Constant.
Huh?
Is it constant? Or no,
Linear. Linear. Number of terms. How many terms are there here, Sage? 2. And that is called a what then, Sage? Binomial. That is a linear binomial. All right, number 5. Frank, how would you write that in standard form?
I just kept it the same. I didn't know what to do.
Put it in standard form. So exponents, highest exponents go first.
Oh, okay, so 2x to the 5th plus 6.
Nice job. So negative 2x to the 5th plus 6. Degree is what now, Sophie? What's my degree? The name for degree of 5. Do you have it, Sophie? Quintic. Nice job. That is a quintic. Number of terms. How many terms are there here, Bailey?
2.
And that is called a binomial.
Good question.
Number 6. Standard form. Phil, what do you get? How about plus x to the third minus 2x squared, right? Okay. Degree is what, Jack?
Oh, quartic.
That is a quartic. Good. How many terms are there, Mark?
3.
And that is called a?
Trinomial.
So I have a quartic trinomial. Nice job. That's classifying functions here. The next part is adding and subtracting polynomials. Okay, so we are adding and subtracting polynomials. As the first period said, this is nothing more than adding and subtracting like terms. Okay, yes, we're talking about polynomials, but really all we're doing is combining like terms.
M is 66, but you don't have 66 on here.
It's not 66.
I think there's a teacher error.
No.
It's definitely 66.
So to add and subtract polynomials, you need to add and subtract like terms. So again, looking up here, you're combining like terms, looking to see what combines, and you just simplify. That's all it is, combining like terms. So if I look at number 7 here, 4x squared plus 6x plus 7 plus 2x squared minus 9x plus 1. I'm looking to combine like terms here. Sean, what would that be if I combined like terms?
6x squared
6x squared minus 3x plus 8 is correct. Nice job, sir. And again, looking to combine x squareds with x squareds, x's with x's, constants with constants.
Is it 69?
I have to look at it. Number 8. 12m to the second power plus 4 plus 8m squared plus 7m plus 5. Again, looking to combine like terms. What do you get here, John?
20m squared plus 7m plus 9.
Nice job. And again, the key here, make sure you put these in standard form. So make sure you put that 7m first before the constant. Always putting these in standard form is going to be key from here on out. And then the last one, number 9. What do you say for number 9, Reagan?
19y to the third plus y squared minus y plus 5.
Plus y squared minus y plus 5?
Yeah.
Is that what you said? Nice job. That is correct. Again, all it is nothing more than combining like terms. Try these next 3 on your own. All right, number 10 here. When you combine like terms, what do you get, Andy?
3x cubed plus 6x
Oops.
squared minus 5x.
Nice job. 3x cubed plus 6x squared minus 5x plus 9. Is that what you said?
Yeah.
Good job. Again, recognize you can combine like terms here with here. Okay? Don't get caught up in always just combining the first ones and the second ones. Make sure you're combining which ones are actually the exponents. Number 11, Garrett, what'd you get?
9x to the 4 plus 6x squared plus 7x.
Plus 6x squared, isn't it 5x squared?
Oh yeah, 5x squared.
Plus what? 7x?
Yeah.
There you go. That is correct. And number 12, what'd you get, Bailey?
X to the third plus 3x squared plus 6x plus 9.
Plus 9? Nice job. That is correct. All right. Adding polynomials is the easy part. It's actually the subtraction of polynomials where students struggle on. Okay? And a couple of different ways to do it. You can look at this as all subtraction and be just fine. Or some students struggle with the subtraction. So instead, they like to distribute the negative. So they add all of the opposites. Okay? Either way works. You're going to get the same answer as long as you work it out correctly. It's up to your preference. Again, for some students who struggle with some of the basics of subtraction, I'd probably distribute the negative and you're fine. Okay? If not, you can just, hey, subtract it and be just fine. So 2x cubed minus x cubed gets me x cubed. Now here's the next one where students make their mistake. It's 5x squared minus a negative 8x squared. So 5x squared minus a negative 8x squared actually gets me a positive 13x squared. That's where students make their first mistake. Minus 3x, we're good. Here's where students make their second mistakes. A lot of them want to say plus 11. We're actually subtracting. So it's going to be minus 11. Okay? So recognize that that negative has to go to everything. And again, if you want to, again, you can change the subtraction to add and add all the opposites, and you're going to get the same exact answer. Okay, so some of you might want to just change all the signs and then get the same work. 14, using either way. What do you think you're going to get here, Sean? Yeah. Okay. So if I wanted to, I could change the positive, change all my signs. One way to do it. But I'm looking to combine like terms there. Let me know when you get it. It's kind of loud. Got it?
Yeah, I got it. Negative 8b to the third plus 13b squared minus 4b.
Nice job. That is correct. Again, remember, 6v squared minus the negative, so I'm adding the 7v squared, so 13v squared. Then negative v minus 3v is negative 4v. Good work. Number 15. What do you think about number 15, John?
Negative 2x squared
Yeah?
minus, yeah.
How about plus?
4x, yeah, plus 4x minus 7.
Good job. Number 15. Negative 2x squared plus 4x minus 7. Nice work. Try these last three on your own. Same idea, subtracting the polynomials. All right, Reagan, what did you get for number 16?
2x squared plus 4x squared minus 6x.
Nice job. That is correct. 2x cubed plus 4x squared, because you're subtracting the negative, making it a positive, minus 6x. Nice work. Number 17. It's a little bit tougher maybe, because there's a lot of the same things. You gotta make sure you distribute that negative or whatever way you work. Andy, what did you get for number 17?
Negative 2x squared plus 6x.
Nice job. That is correct. Negative 2x squared plus 6x. The negative 4 minus the negative 4 is negative 4 plus 4, which cancels out. And 18. Phil, what did you have for number 18?
I have 11 points. 3x cubed plus 2x squared
Minus 2x squared.
minus 2x squared plus 2x.
Nice job. That is correct. 3x cubed minus 2x squared plus 2x is correct. And again, this is really just combining like terms. All right. The toughest thing that you're going to have to do today is, if you can recall, these classifying. Again, this table will help you. If you want to just save that somewhere on your iPad so you can just keep referencing it, that'll be the toughest part today, is just classifying them, keeping them all straight. Here is your assignment.